Good day and welcome to MCC Tech Days. Tech Days are in response to the unfortunate cancellation of the IMTS show. We're going to wait a few minutes and allow others to join us in watching our videos and our demonstrations. While we wait, you should know that MCC is blessed with extraordinary support from our dealer network. Unfortunately, this year they can't really show it. They have, however, given us some really wonderful videos, the first of which is from Allendale Machinery. So sit back, relax, and enjoy it. Thank you.
Allendale Machinery is a third-generation company. We were started in 1981 by my grandfather. Prior to that, he had worked with many different machine builders and distributors throughout the country from the early 50s. After serving in World War II, he went to Georgetown on GI Bill and then started working in the 50s and brought in a lot of the machines you see today. We now have our third generation. My father and my uncle, Marty and Andy, are the ones running the company and pushing it forward even farther. With that, we've slowly grown and taken on many different lines and products. We've gone from just being a machine tool distributor to being a full service company, offering our customers tooling, service, applications, training, and really just helping them find the manufacturing solutions they need to grow. Allendale as a company is looking to help our customers compete globally in the manufacturing market space. We're really trying to be the ones that support manufacturing in the United States. We're doing this by offering our customers manufacturing solutions that are going to allow them to be efficient and be competitive in that global market. Helping customers pick the right equipment, helping them maximize that equipment by giving them proper training, by having our engineers work with their people to optimize any programs or any tooling they're working with. And then in the end, keep the solutions up and running with service, being there ready with parts and the expertise needed to keep them making parts, making sure that all is up to the standards that we've set for ourselves. Our hope is that when they work with Allendale, they come to realize that we can offer some great solutions for them, and from there move forward and work with them on other projects.
This machine is a Citizen-Cincom L20, primarily used to make long and slender components, milk turn, but you can also do short components as well. Really strives in a production type environment, high volume, short cycle time, multiple shifts a day, holding tight tolerances. This machine is typically seen in the medical field, aerospace, defense, a little bit of industrial as well. Really covers a broad span, more geared towards high volume environments where part tolerances are critical.
Allendale offers engineering support for machines like the one behind me. If you are a customer that may already have one and you need to make a part faster or with a better surface finish, or if you have parts coming in that you've never produced before, we can sit down and help program, tool up the machines, get them set up and get you running. For our medical customers, we'll even help assist with the validation and make sure the parts are up to spec and approved by the medical industry.
Key features of this machine is it can perform multiple operations at the same time. You can do milling, you can do turning. Both sides are working at the same time, op 1 and op 2, so it really reduces the cycle time a lot. A lot of different functions can also be performed, such as gear hobbing, polygon turning. The sky is really the limit with this machine on what you can do. Extremely repeatable, quick, small work envelope, decent amount of power for the size of machine it is. So the part that I'm running right now is a bone screw, heavy medical application. It's a long and slender part. We're running it in aluminum for this demonstration so we can run with the coolant off so you can really see what's going on. Once you turn that flood coolant on, just becomes a monsoon in there. You really can't see anything moving around. Typically, bone screws come in a variety of materials ranging from titanium, cobalt chrome. All of those materials really need the coolant on. So for this demo, we were doing aluminum. Key features on this particular setup, the primary one is the thread whirler. It allows us to cut long thread in one pass. This is important for a Swiss type machine because you shouldn't be drawing back into the guide bushing. You can only cut roughly 3/4 of an inch at a time. The thread whirler allows you to cut up to the maximum stroke of the machine in one pass. Multiple inserts spread out the load over the course of the threading operation. Another accessory in this machine will be our spindle speeder. It amplifies the speed of the machine. In this case, I'm running 6,000 RPM on the machine motor, but the spindle is outputting 24,000 RPM at the tool. On the main spindle side, we're using turning, milling, and thread whirling. On the sub-spindle side, we're using turning and milling as well, but the milling being the spindle speeder, so we're actually achieving a very high spindle RPM. We also have a part ejector that allows us to spit the part out at the end of the cycle and repeat to the next one without stopping. To optimize the process in this particular application, I was able to speed up some of the backside work. Reason that's really beneficial on this machine is you're working both sides at the same time. So any second that it's idling on the backside is just free time that you can gain. So I was able to bring more work to the backside to balance the cycle time out and actually decrease it as a whole, part to part.
Welcome back. Before we get started, we have a few words of wisdom from our Executive Vice President, Brian Such.
Welcome to MCC Tech Days 2020. I'm Brian Such, Executive Vice President of Marubeni Citizen-Cincom. And on behalf of the entire MCC team and our national distributor network, I would like to thank you for joining us today. As we changed plans after IMTS was canceled, we knew we needed to create our own alternative to IMTS. Our outcome is to offer 4 days of live demos streaming from all 4 MCC offices, demoing Cincom and Miano machines, our tooling and accessories, along with our automation department offerings, all of our MCC technology. We also always have heavy dealer support to our IMTS efforts and knew we wanted to include our dealers in these tech days. Please enjoy this next demo. We invite you to ask questions live as needed. Our team is happy to answer any questions you may have. After each session, we will share some videos from our distributor team and also update all with our promotional efforts along with financing options. Thank you again for joining us in MCC Tech Days.
So here we go. Your presenters today are from our MCC New Jersey office, 2 of the most experienced and knowledgeable people I have ever met. First off is Tim Duffy, our Eastern Regional Sales Manager, and also Ray Navarro, our Applications Engineer. Sit back, relax, and enjoy their presentation. Thank you.
Hello, my name is Tim Duffy. Welcome to the headquarters of Marubeni Citizen-Cincom, located in Allendale, New Jersey. We are one of 4 locations located throughout the United States. From this facility, we employ about 40 personnel, some of those personnel being parts personnel, warehouse personnel that are located actually in a building just next door. In this building, we have our service and applications department, engineering support teams, sales and marketing, administration, and our accounting department. Today, we will be reviewing the L20 Type 12 ATC machine. This is a 20mm sliding headstock lathe with a B-axis and an automatic tool changer. Later on, we will review the Miyano BNX 51 MSY machine. This fixed headstock lathe that is well suited for bar work and dropping off parts complete. So here we are at the L20 machine. It's an L20 Type 12 ATC machine. ATC machine, like tool changer. We've installed a 12-station carousel tool changer on this machine. What we're going to be looking at is the part being cut. We're also going to be looking at the various axes on the machine, including the tooling and various options that might be purchased with the machine. So we're going to show you a part being cut and explain various aspects about the machine. I hope you enjoy. Hello, my name is Tim Duffy and welcome to the presentation on the L20 Type 12 machine with ATC. The L20 machine is a 20mm Swiss style lathe. The Swiss style lathe, where the bar stock is fed through a guide bushing. As the bar stock is fed through the bushing, it is supported and the gang tools come down and machine the part. Through this method of machining, we can machine long, thin parts without the aid of a center support. This particular machine it has ATC attached to it, so it might not warrant itself for a lot of these long, slender parts. It warrants itself more for a lot of complex parts. In other words, many live tools. There's various configurations of the L20 machine. Say this happens to be a Type 12 machine. The Type 12 machine has a total of 9 cutting axes. We'll start off, we'll just have a look behind the control at the main spindle. On the main spindle side, we have the spindle. The spindle has a Z-axis. The Z-axis will move back and forth, control lengths on the part. The stroke on this L20 machine is approximately 200mm. So we've 200mm of travel. If we want a machine longer than that, we'd basically do a rechuck. We'd grab with the sub spindle, then grab more material. The main spindle itself is a 10,000 RPM spindle. That spindle has a full C-axis. Full C-axis on the main spindle. Also, the main spindle is actually oil cooled. So with the aid of the oil chiller, the oil cooler, it's a very stable as far as machining with that spindle. Obviously, when we machine the spindle, any movement on an axis creates heat. This minimizes any heat that's affecting the machining area. We can also convert this machine from a guide bushing machine to a non-guide bushing machine. Attached to the main spindle, we can see a belt. To change over to non-guide bushing, we basically detach the belt, swing the belt to the side. So the belt is actually driving a shaft that's driving the guide bushing. So we remove the belt, then we will remove the guide bushing housing itself, and we'll replace the spindle cap nut with a different cap nut to allow us to extend the spindle to move forward, basically through the area where the guide bushing is at this point in time. We can also convert this main spindle over to a 25mm diameter stock. It's basically we'd have to change out the guide bushing and we change out the cap nut on the main spindle to accept different size collets. The collets on the main and sub spindles on this machine are TF25. Now we'll move across to the main cutting area on the machine. The main cutting area, above the guide bushing, we have a gang plate. So we have a gang plate with an X and a Y axis. At the front side or on the right side of that gang plate, we have 5 turning positions. First position is 5/8. The other 4 are 1/2 inch for 1/2 inch shank tools. Also located, where you can see this cutoff tool is a small stylus. That stylus basically is a cutoff breakage detector that is standard with the machine. Just to the left of those gang tools, we have 2 spindles, 2 live spindles in the cross location. These spindles are 9,000 RPM spindles. If needed, we can remove these spindles and put speeder units up to 4 times in those positions. We'll move further over, we can see this axis, or this set of tools. There's 2 tools there. That is actually a B-axis. The rotation on that B-axis is 0 to 96 degrees. So 0 basically would be if we were using a live tool on the face of the part. We can swing it from that location to any location and machine with the B-axis around through 96 degrees. The particular holder you see on the B-axis, the top position is basically a built-in spindle. The lower position accepts tools from the ATC. The ATC is actually the 12-station carousel you can see at the far side of the machine. The RPMs on the B-axis are 12,000 RPM. The tool change time for the tool in the lower position to exchange a tool with the ATC is approximately 4 seconds. With adding the ATC, we actually add 2 more axes to this machine. They're non-cutting axes, but the motion of the B-axis to go and basically pick up the tool or to move forward, that is known as the A5 axis. The rotary motion on that carousel is basically what we call the A6 axis. The test part that we're going to be running on this machine uses the ATC tool changer multiple times. Many live tools are going to be working on the part at various angles utilizing the B-axis. We use the B-axis at a certain point on the part, I believe the surface mill. Continuing viewing inside the spindle, the main air cutting area I should say, the spindle on the sub-spindle side is a 10,000 RPM spindle. That spindle has also a full C-axis. The slides on the sub-spindle, we have an X. The X is basically back and forth in a horizontal motion. We have a Z-axis in and out where we go in and out to pick off a part or control lengths on the back of the part. In addition to the X and Z, we have a Y-axis on that sub-spindle. So that sub-spindle moves up and down. The fact that it moves up and down, what we have is we've 2 sets of 3 rows of tools next to the sub-spindle. Traditionally on the L machine, in the past, we just had 1 set of 3 tools. So we got an upper set and a lower set on this machine because we got the Y2 axis. The 3 tool stations on the upper locations are live. Those are 7,500 RPM spindles. 3 lower positions are fixed positions. Put in drills, boring bars, tools of that nature. In the upper position, we can put in various different live tools. Traditionally, it's a face live tool. but we have 90-degree angled holders where we could utilize in a dog leg fashion, where we could pinch mill on the front of the part. So we could use 1 mil on the sub spindle side coming up towards the main, and then one of those gang tools to machine the flat on the part or something of that nature. Continuing viewing on the inside of the machine, we got these back working tools. The back working tools got an upper row of 4 and a lower row of 4. The upper locations are live. Once again, these are 7,500 RPM spindles. The lower ones are fixed. The lower positions on both the next to the sub spindle and on this back end accommodate 3/4 inch sleeves. On this back end, we actually make tandem spindles. So basically, we'd put a tandem spindle in the upper location for the live tool, and that's basically attached to another live tool. It's geared to one of the lower locations. So we can increase the capacity for live tools on that back work block. We have numerous live tools available for both the front side and the back side. We have high-speed spindle systems up to 80,000 RPM. The tools on the front and the back are interchangeable. If we're not using the live tools, we can use sleeve adapters in those locations that would handle stationary tools or fixed tools. Inside the sub spindle, we have a pneumatic work ejector standard. The servo ejection system is also available for this machine. We also make long workpiece devices where if we had extremely long parts, we can feed them through the sub spindle onto a tray at the side of the machine. So we've got long workpiece devices, we've got work conveyors, we've got gripper ejection systems. Our tech center in New England have developed a lot of excellent accessories for these machines, Swiss machines and our Miano line of machines. Gripper systems are very popular with bone screws, wire ejection systems. Once again, a wire injection system would basically be with a spindle liner like a long workpiece device, except the part would be pushed through the sub spindle one at a time. Traditionally, a long workpiece device would go and pick up the part, would grab that part, maybe do some machining on the back end. And when we pick off the next part, that part would push the previous part through the spindle. So you could damage parts if you had trocar type parts, parts with fine detail on the end. This wire ejection system would be very beneficial in that application. For extremely small parts, our tech center has developed vacuum ejection systems. Any of these units could be coded for your application. Many of the options are available. I briefly mentioned the high-speed spindle systems. High-speed spindle systems that are air-cooled up to 80,000 RPM. We have thread whirling systems. Thread whirling systems make the manufacture of bone screws relatively easy. For any of the options on this machine, please contact your distributor. They can certainly provide us with the prints and we can look at the part and see if it applies to one of these special options. What I'd like to do now is just walk over to the carb bar loader. The carb bar loader was specifically designed for our Cincom line of machines. Once the bar loader is attached to the machine tool, that is fully controlled from the control on the machine. Not only that, the bar feed or the pusher on the bar feed becomes an axis on the machine, becomes an A7 axis. So basically that A7 axis, as the parts being machined, will follow the motion of the Z1 axis on the main spindle. So inside this bar feed, we have a rail. This rail on this machine is approximately 9 inches long. We can put up to 12 20mm diameter bars in this rail system. So when a bar is loaded, basically it lifts the push out the way. A lot of bar feed systems have 12 foot for the bar, then they have an additional 3 foot, 4 foot for the pusher. On this machine, when it loads a bar, it swings the push out the way. So we don't have a bar feed that's 12 foot plus 3 or 4 foot. It's very compact in design. So the pusher swings out the way, the bar falls into the channel, the pusher comes back down, the gripper grips the bar, we push the collet on the back of the bar. So the material is supported by the channel set. The carb machine comes with 2 channels as standard. So you buy the carb, 2 channels are standard. We do have different sizes. If you want to extreme small stock, you might go with a different channel size. So the bar is supported by the channel set. In addition, there's oil that's pumped into the channel. Oil is pumped into the channel as the bar spins. The oil clings onto the bar stock and creates a hydrostatic effect that further stabilizes the bar and dampens vibration. In addition to the channel set and the oil dampening the bar, if we move down on the inside of the bar feed, on the front end, we have a set of rollers. So additionally, the bar is supported by the rollers inside the bar feed. So as the pusher moves forward and the bar stock gets shorter, once it comes to the pusher, these grippers will open and allow the pusher to pass through. Additionally, on the back of the main spindle, I just opened the cover, we have a further set of rollers on the back of the spindle. So these rollers, like I said, the bar feed is fully integrated with the machine. So when we open the collet to grab more bar stock, the machine actually opens these rollers also. So you're not dragging the rollers across the bar stock. So now I'd like to hand you over to my colleague Ray Navarro, who will go over a part being machined.
First operation will be our phasing off. Following, we're going to be changing mode to G610, System 1, single machining. It will bring U128B towards the guide bushing and work with 220s in the front face of our part. It will have 3 operations, spot, drill, and a rigid tapping, as you can see. Now we're going to switch to mode G630, front and back paddle machining. It will allow us to work front and back on both systems. Main side right now, it's roughing, turning, using LFB mode 1, while working, as you see, back side. This is our first tool change performed by using M346 and E as an argument. Following the process that involved the axis holder, we're using G900 and G950, which are the axis on and work piece coordinate rotation command. We're using a 3/8 end mill, and as you can see, we're doing many different angles. Now it's going to change tool again, and it will be a 1/4-inch end mill. And at this time, we're doing a helical interp using the 1/4-inch end mill. And also, it will do some face at 90 degrees. Now it's going to change the tool, kind of as a pre-call, but it will use T11. And T11, it will divert some of the edges around some of the fixtures, and also it will spot some holes. After that, now around the boss that we just made, it will make a dread. Also, it's using helical interp as a strategy. As you can see, it keeps working both systems at the same time. Now, it will be next tool call, which will be an 85 thou drill on the center of the bus. Following tool will be a 3mm drill, and it will go around 4 holes. Following by a 1/8 end mill, which will be a wrap contouring, doing a slot over the round surface. Now it's doing Cincom engrave with tool 8. Tool 8 is being set as a master tool. You will notice later on it will change to tool 7 because 7 is our spare tool, as you can see. This is being set on our tool life management. It's really simple, and it's a great feature that pretty much all new Cincom has. Then cleaning up that diameter, start grooving using G75, also using LFP. We are cutting in brass for video purpose, but the speed and feed are being set to stainless steel 303. It's still working in the back. Soon you will see at the back, it will be ejecting the part. This will be the last process with the MEU 110 holder, which is the B-axis. Following and next, picking up the part and cut it off. Also, cut off is being used LFB. Now we notice it's time for bar change. The machine has received the end of the bar signal, and the calf will execute a series of operations and load a new bar. The calf is fully controlled and synchronized with our M70 control. The calf is the best way to go on our Cincom lathes. With this, we have concluded the ATC demo part. Please stay around and continue watching our next machine presentation on our MCC Tech Days.
Good afternoon, everybody. My name is Ray Navarro, application engineer at the headquarters office here in New Jersey. Welcome to MCC Tech Days. Today, I got the privilege being working for you guys under the ATC machine. I want to start saying thank you for joining us, and I'm going to show you. So ATC machine, it's really a state-of-the-art machine that came. It's really a standard type 12. This is the holder, you can see for the standard type 12 machine. If we get the option for the ATC, or we get the ATC, this will be the holders, right? MEU 110. This will be the holders that we call BT15 that goes into station 12. These are our parts I want to show. So it's a unique machine for very complex part that we can get it done. Talking about the footprint, this machine, it's like I say, standard to the type 12. And the only thing I will point out is just have 472 millimeters in the back side of the machine that holds the whole mechanisms of the carousel and the slide. So now I want to talk about a little bit about M70 control. M70 control, it's a unique system that realize fast and smooth operations. Display easily of understood illustrations, equipped with high-speed NC, uncheck function, code list display, and much more. So now I'm gonna start going through MC data. MC data, or machining data, is utilized by the machine to gain information for the current job that is running. Into the MC data, you can set bar stock. As you can see, it's highlighted in yellow. Tool positioning data, tool position point, sorry. Cutoff tool number, cutoff speed, cutoff feed, cutoff end diameter, and there's some others. Like this one, you can also swap guide bushing less. Second page of MC data, this is how the machine recognize which holders are being used for the job that you want to run. So as you can see in the MC data, so right now you see MEU 110. This is so user friendly. So you can see here, every holder, it's identified with the number that we call MEU 110 in this case. All the rest holders has their own name. So now I want to show, you can see inside the machine where we had the machine. Right now, it's kind of like, this is not how we start running anything, right? But I want to show the A5, which is the axis that comes forward and retract. A6 is the rotational axis that holds all our tools on the carousel. And this machine and the beauties of Citizen, they have been developed specific for ATC. They have a specific HMI screen, which I'm going to show you right now. ATC. So this is the screen that mainly we use for setting up tools. You can manipulate anything from here, regardless the ATC, as a tool change, tool store, take the tool, index the magazine, shutter open, shutter close, air blown, magazine retract, and back spindle retract. I want to point out, and probably some people will wonder, hey, but how this machine works. All right, so tool 12, it's always the ATC. 11 is the build up. So in the program, all the time, tool 12 will be tool 12. And the way that we set up the tools, it's using tool 12 as normal. So in this page, if you have the pocket empty, so you will place the holder with your tool, and then as soon as you set tool 12, like normal we do, that people that know Cincoms, but those one doesn't, who doesn't know, so you will use that diameter, then touch off your bar stock. Then if you had let's say number one highlight as yellow, so you will store that tool, and the magazine is so smart that always remember where the tool is it's located. So I'm gonna try to show right now using, if you see in the machine we have the A5 kind of toward the front. So from this page, I'm gonna say magazine retract. Magazine will go all the way to the back, zero position. I want to close my shutter, so 6, close. Now I'm gonna do a position point, right? And I'm gonna position point, and I'm gonna try. I want to show one of our greatest fixtures. Cut off. I'm gonna cut off. This is a great machine. So right now, I'm just trying to. I'm gonna show now handle and check function. So I'm gonna track this. So if you see here, now I just hit cycle start. I have my machine. I'm gonna hand wheel. The great advantage of hand wheel, you can move forward your program, and if you decide to stop, it will stop. Also realize that in the check mode, you can stop your machine, do any edit you desire in the fly, and go back and keep going. This is how Citizen all right. As you see, machine is moving. I'm going to show this. Start my facing. So let's say right there, I want to stop my machine, so I can just hit one block. After that, I can say correct. Oops, I'm going too fast. So as you see, now it will allows me to make any edit if I want, then continue. So only thing you have to do is just hit operate, and then you can keep going. So let's keep going. So I'm gonna stop right there. Now I'm gonna reset the machine. This is just showing one of, to me, it's the greatest fixture that when you're setting up machine, this will be awesome. I'm gonna restart. So now, going back to the ATC page, I want to show you how you can perform a manual tool change. So, ATC. So right now, as you see here, we got number tool 1, it's selected. Right? So, let's say I want to store that tool. So, you see here, we got 10 options. We got number 2 will be tool store. So, only thing I have to press is to input and cycle start. I will recommend usually bring the stock inside the guide bushing just for safety. So I will do that right now. Okay, so I'm good to go. ATC, I hit tool 2, store. Going slow with feet hold slow, just everybody see, placing the tool on station 1, going out. Now I have tool 12 holder empty. Let's say now I want to grab tool 6. If you can see here, so only thing I have to do is just highlight station 6 and say tool take, input, cycle start, inside. It's going tool 6. You see as the magazine index for 6. Grab the tool, going out, and done. So I just want to show this. Probably people will be wondering about how we set the tools. It's really simple to set tools here and run this machine. Use the same code as standard machine. So hope you enjoy. Now we're gonna play, and also I gotta thank you, all my team at this office, everybody, thank you, and hope you enjoy. So now we're gonna play Dynamic, our dealer's video. So thank you.
Yeah, we'll be missing this section.
Welcome back. We are now open for question and answers. Do we have any?
Yes, Tim, we do. First question, what is the benefit of using the machine without a guide bushing? Also, will it lose rigidity running guide bushingless?
To run the machine without a guide bushing, basically would eliminate any imperfections by the bar stock. So a Swiss machine, the accuracy or the roundness of the part is all determined by the quality of the bar stock you're putting into the machine. So we run non-guide bushing, we could run it more like a traditional lathe. So we'd get actually better roundness certainly if we weren't using ground bar stock. Obviously the drawbacks is you lose your support running guide bushingless. So as far as the max length, it's like a traditional lathe. You really don't want to be running any longer than 2.5 times the diameter. This machine being a 20mm machine, you probably wouldn't want a machine without the guide bushing in a part any longer than 15mm, worst case scenario on 20mm diameter. The benefit, obviously, of going non-guide bushing also is our tech center have developed a loader system. So you can actually load slugs into this machine. So they made a loader that transfers parts from a pallet system. From the right side of the machine, part gets loaded into the main spindle. The main spindle moves forward. We do the machining on slugs. So a non-guide bushing scenario or setup would be ideal for that sort of condition.
Thank you. Can you use a spindle speeder with the ATC unit?
Hey, back again. Not really. MEU 110, it's 12,000 RPM, so the answer is no, you can't.
Can a probe be used with the ATC?
Right now, I will say no, but I will hope our designers in the near future, probably I will say yes.
Okay. Does the ATC unit have an air blow pipe for cleaning up chips or a sensor that stops the machine from grabbing a dirty tool?
Yes, it has. I show in the presentation, there's some option under the ATC HMI screen that shows air blow on, air blow off. Also, over the tool change, also it does that.
Okay, thank you. Can the machine be started in the middle of a program?
Usually, Swiss machine, you cannot do that. No.
Okay. How fast does it take to perform a tool change?
Really fast. It's about 4 seconds.
I see. Thank you. I'm going to give it a little bit of time because there's a delay on questions, but do we have any other questions from our audience? I'm not seeing any other questions.
Tim?
Seems like that's concluded the questions. Basically, it's time to wrap up this presentation on the L20 Type 12 ATC machine. Before we go, I'd like to mention that we have some special financing options through US Bank for a limited time. There's a deferred payment option where there are no payments for 5 months, then 55 equal payments. The structured payment option, which is 9 months at 1% of the financed amount, then 51 equal payments. And finally, a fair market value lease option, or FMV option, which is 3 months at 0 money, then 57 equal payments. Your distributor can supply you with further details. Please join us later for a review of the Miano BNX 51 MSY machine.
As we get ready for our 230 BNX presentation, please enjoy a few demo videos prepared by some of our distributors. I want to mention, as hard as we work to service our customers and support our dealers, they work just as hard in supporting us. So please watch these videos. It's a little bit of indication of just how hard they work for us. Please enjoy. Thank you.
Hello, I'm Randy Heck with Precision Machine Tool Solutions. We are the Mid-Atlantic distributor of Miano and Citizen-Cincom machine tools. Behind me is an awesome machine from Miano, the BN842 MSY. With its rigid boxway configuration and a total of 7 cutting axes, simultaneous machining of highly complex parts from bar stock is what Miano Precision is all about. The BN842 MSY has a 42mm bar capacity, main spindle, sub-spindle, with a single turret, including a Y-axis. This machine will outperform most all other machines in its class based on 2 of its most important features: the X2 axis on the sub-spindle and the simultaneous machining capability. In this video, we will show you some basic simultaneous OD/ID machining. But before we get into the cutting, please pay close attention to the details so you can understand what having an X2 axis and simultaneous machining can mean to you in reducing cycle times, cost per part, and a greater return on your investment into a new Miano machine tool. Thank you.
Hello, and welcome to MCC Tech Days. My name is Mark Zarbach. I am the bar loader product manager for Marubeni Citizen-Cincom. Today, I would like to show and explain a new technology that we've been working on for future development on our A320, C320 bar loader. We have developed an Ethernet link between the A320 and the C320 that will give us almost real-time communication between the machine and the bar loader. Not just signals, but actual data. With this, we can now send information from the program to the bar loader by using macro variables like overall length of the part, short feed safety, long feed safety, and torque setting for the pusher. We also receive from the bar loader using macro variables like bar remaining, parts remaining, and pusher position. And here's an example of almost real-time info sent from the bar loader to the machine. As I move the pusher by hand, see custom macro 443. Now with this type of information being sent through the program, if the operator or the setup person forgets to send the bar loader info, the information will be sent by program. We are also working on having this information of parts remaining and pusher positioning showing up on our operator screen. Another new feature that we'd like to add to our bar loaders is last bar sensor. So if the lid is closed and the machine isn't automatic and the last bar is loaded into the channel, now with the lid still being closed, we have a warning light blinking that states that there are no more bars left in the bar loader. Please be on the lookout for this option and Ethernet connection between the C320 and the A320 in the near future. Thank you for your time, and please continue on watching the MCC Tech Days. Thank you.
Hello again. Please enjoy a few more demonstration videos prepared by our distributors. Thank you.
Welcome to Spinetti Machinery. We are a very focused distributor concentrating on Marubeni Citizen-Cincom CNC Swiss, Citizen Miano CNC lathes, and FOBA laser markers. We pride ourselves in representing the finest equipment in their categories, attention to detail, and providing the highest level of service for our customers. The turnkey project we did for this customer is one of many examples of that. Now let's look at today's demonstration. We are pleased to have you with us today as part of the Marubeni Citizen-Cincom IMTS Demo Days for 2020. Today, we will be demonstrating a gear hobbing application on the Citizen L220 Type 10. A little about the machine. The L220 Type 10 is a 20 millimeter machine with a 25 millimeter upgrade option. It has the capacity of up to 34 total tools and has a Y2 axis on the sub for additional machining capability. Some features of the beveled gear project. We are using a gear hob attachment from Marubeni Citizen-Cincom, New England division. We are using the LFV function or low frequency vibration. That's part of the latest in the Cincom technology. The gear cutter is a special 3-tooth cutter from Gen Swiss. The goal of the project was to successfully make a pair of identical bevel gears to mate together in a housing designed by the customer. Originally, the customer was making a single gear in 5 operations, whereas we are now making the gear in a 1 complete operation. This project is this beveled gear, which is not a common thing to do on a screw machine. This particular beveled gear, instead of being at a 90 degree, it is at a 57 degree, which is even more unusual to run on a screw machine. This particular beveled gear required us to use this 3-tooth cutter, which acts more like a single tooth cutter than the normal cutter that we would use for a spur gear. We also 3D printed this particular fixture to hold the 3D printed gears we made of their printed part so that we could get a better understanding in the very beginning of this project. The customer's actual unit that they're doing this in is this one here, where you have 2 of these side holders that hold the gear that then fit into the housing, whereas then the beveled gears will drive each other. Thank you for joining us today. I hope you got a small glimpse into what the Citizen-Cincom Swiss CNC machines are capable of. Thanks to the Marubeni Citizen-Cincom New England office for the gear hobbing attachment. Thank you to Gent Swiss Tooling for the 3-tooth hobbing cutter and the turning tools, and Harding for the collets, and our customer for allowing us to showcase the part. If you have any questions, visit our website at spinettimachinery.com or send us an email at info@spinettimachinery.com. Have a great day and stay tuned for more to come from Marubeni Citizen-Cincom during IMTS week.
Pretty good, pretty good. I liked it. Okay, enjoy this one from Millennium Machinery. Thank you.
Hello, I'm Derek Bolin with Millennium Machinery. Today we're going to show you a few features on the D25 with LFE. We're going to do some pinch turning with LFE, some programmable B-axis, and some high-speed milling.
Here's another video, this one from LG Evans. Please enjoy it. Okay, that was good. I enjoyed it. I hope you did too. Now please enjoy some videos from our automation and laser department.
The Marubeni Citizen-Cincom laser system L2000 is a 10-micron fiber optic system offering high-precision, high-speed laser cutting and welding. Incorporating the L2000 on a Cincom Swiss-style lathe or Miyano multi-axis turning center provides the capability of combining conventional machining with laser cutting and laser welding on a single machine platform, reducing part handling and ensuring improved part accuracies. The L2000 utilizes the IPG photonics fiber laser systems. IPG is the world leader in providing fiber optic lasers and is fully supported in the US. Multiple power units are available that address specific application requirements. One option is a QCW, quasi-continuous wave 300-watt system that can provide power bursts to 3 kilowatts for extra power when needed. The laser head assembly mounts on the gang tool slide of the Cincom machine. The movements are programmed in the part program of the machine control. The unit has the unique capability of also mounting on the B-axis tool position, allowing for laser cutting at various angles for components that require angular laser cut features. The laser head assembly is liquid tight, so it's capable of operating while high-pressure coolant is flooding the workpiece during the machining process. Internal air pressure protects the lens and internal components. High-pressure coolant that is used during the cutting process also feeds coolant through the tubing material in the auto-loading bar feed system. This provides a flushing of dross or chips that are created during the laser cutting process. An integrated custom-designed CCD camera for optical viewing and alignment is included for XY beam alignment to the nozzle. The live camera view is visible on the included touch monitor. This greatly reduces setup time. The L2000 is completely interfaced to the Cincom control. Cutting path, offsets, laser cutting parameters, laser focal point, and gas pressure are fully controlled and edited in the machine control. One of the unique features of the L2000 is that it's a modular system and not designed for a specific model Cincom or Miyano machine. The system can also be retrofitted to some older model Cincom machines. For additional information, please contact Marubeni Citizen-Cincom at marucit.com or your local Cincom distributor.
Okay, just please enjoy a few more demo videos from our distributors while we get ready. Please stay tuned. We're almost there. Thank you.
Hello, and welcome back to MCC Tech Days. Before we begin the BNX 51 MSY presentation, I'd like you to hear a few words from our Executive Vice President, Mr. Brian Such.
Welcome to MCC Tech Days 2020. I'm Brian Such, Executive Vice President of Marubeni Citizen-Cincom. And on behalf of the entire MCC team and our national distributor network, I would like to thank you for joining us today. As we changed plans after IMTS was canceled, we knew we needed to create our own alternative to IMTS. Our outcome is to offer 4 days of live demos streaming from all 4 MCC offices, demoing Cincom and Miano machines, our tooling and accessories, along with our automation department offerings, all of our MCC technology. We also always have heavy dealer support to our IMTS efforts and knew we wanted to include our dealers in these tech days. Please enjoy this next demo. We invite you to ask questions live as needed. Our team is happy to answer any questions you may have. After each session, we will share some videos from our distributor team and also update all with our promotional efforts along with financing options. Thank you again for joining us in MCC Tech Days.
Hello, my name is Tim Duffy, and welcome to the review of the Miano BNX 51 MSY machine. The BNX 51 MSY machine is a twin spindle single turret machine. The machine has a total of 7 cutting axes. What makes this machine unique is the subspindle has not only a Z-axis, it has an X-axis that allows us to have a lot of flexibility, I should say, in machining the front work and the back work simultaneous. We'll see that later on when I run the test part. The machine is constructed on a one-piece casting. That casting is a platform design. That platform design helps us maintain flat surfaces and reduce distortion. So it's a very stable and extremely rigid setup for the foundation of the machine. Slides on this machine are boxware and hand scraped. On the left side, we have the main spindle. The main spindle is a 5,000 RPM spindle and 20 horsepower. That spindle is supported by 3 sets of bearings at the front. 3 sets of bearings comprise of 2 sets of cylindrical roller bearings and 1 set of angular contact ball bearings. The roller bearings absorb axial loads, where the angular ball bearing accepts lateral loads. At the rear of the spindle, we have 2 bearings that are cylindrical roller bearing design. So having the 2 on the back, it really stabilizes the spindle. This machine was designed to run 12-foot bars. So the fact you're running 12-foot bars, you certainly want additional support at the rear end of the spindle. The spindle nose itself is an 826 design. In front of that, we have an S22 hard-hinge colored pad system as standard. The main spindle has a C-axis. Along with the C-axis, it has a brake. That brake can be used when we're doing any heavy milling. Above the spindle, we have a fluid coolant system used to clean the part off to get coolant at the cutting area on the front side. Just to the left of that, we have an air port the air port or an air blast that can be used, programmed to blow air and blow chips off the part. Moving on to the turret at the far side. The turret is a 12-station turret. That turret has an x-axis for diameters, y-axis, and a z-axis. The z-axis travel on this machine is 300 millimeters. The y-axis travel is plus 40 millimeters, minus 40 millimeters. So that's above center 40, below center 40. Each one of these 12 stations on this turret can handle a live tool. The drive for the live tools on this machine is tang drive. So one tool is driven at one point in time. So there's no torque loss that is lost through a gear train within that turret, or you're not driving every single tool on the turret when you start up a live tool. The max RPM on those live tools is 6,000. The horsepower of those spindles is 5.3. Plumbed through the turret is standard. We have a medium pressure cooling system. That medium pressure runs at approximately 145 psi. The standard tooling package that comes with the machine includes cut-off holders, turning holders, and drilling holders. The turning holders accommodate 3/4 inch stick tools or turning tools. The drill blocks accommodate 1 inch diameter sleeves. There's many combinations of live tool holders that are available for that turret, including multi-position live heads, double cross, quadruple face, front live cross, back live cross, and also speeder units. Speeder units obviously increase the RPMs from 6,000 to 12 on a 1 to 2 setup. The machine incorporates a central lubrication system that lubricates all the slides and the drive unit on the live tools. Located on the right side of the machine, we have the sub spindle. The sub spindle is a 10,000 RPM spindle. Sorry, 5,000 RPM spindle, 10 horsepower. The spindle bearing layout is the same as the main end, the 5 sets of bearings. The nose on the sub spindle is 110 millimeters flat. And it's also standard with a hard hinge S22 pad system. That sub spindle also incorporates a C-axis along with a brake, just like the main spindle. As I mentioned earlier, the sub spindle has a Z-axis and an X-axis, the X2 axis. So having that X2 allows us to machine the part on the main spindle utilizing the X1 and Z1 of the turret. Independent from that, on the back end, that you can see a double turning block. So independent of that, on the back end, we can be utilizing the X2 and Z2 and machining a totally different part profile on the sub spindle. Above the spindle, we have another coolant line We've got a coolant line for cooling the part on the subspindle side. We've also got an air port on the subspindle side. Within the subspindle, we have a pneumatic ejection unit. That ejection unit, we can program an air blast, clean chips out of the collet. We can program the medium pressure coolant system to flush chips out of the collet. So the part is ejected. The part is ejected into the parts catcher that's attached to the subspindle. It would swing up, catch the part, the ejection unit will move forward and knock the part out. That parts catcher can come forward and catch a part off the main spindle. If there's no desire to do any back work, we can just machine on the front and cut off. If you have a short bar loader where the remnant might be pushed out the front of the machine, we can utilize this basket to come up and catch the remnant at the end of bar. The machine also comes with a work conveyor. It's standard. The work conveyor, the parts catcher drops the parts into the work conveyor and transfers them out the right side of the machine. We also have a chip conveyor as standard, a hinge belt chip conveyor. If we have long parts longer than 150 millimeters, we can feed those long parts, maybe shafts, through the subspindle with the use of a long shaft work device. That device can handle parts up to a 36 millimeter diameter. I'd like to move over to the bar loader. The bar loader is a Cav 51 MF bar loader. We'll take a look inside. The rack system is approximately 12 inches wide. So this being a 2-inch diameter machine, we could get 6 2-inch bars in this rack system. Now, just like the carbs on our other Swiss style lathes, this carb is fully controlled from the control on the CNC. So the bars are loaded into the channel. The channel swings out the way. Once again, the pusher is an integral part of the bar feed. This is a 12-foot loader. There's no additional area for the bar pusher to go. We basically, when we open the channel, it removes or extracts the pusher. So the pusher moves out of the way, drops the bar in. The bar is pre-fed to the gripper system. The pusher is inserted on the back end of the bar and moved forward. So the bar is supported by the channel set. In addition, oil is pumped into that channel and is used to stabilize the bar. So as the bar spins, the oil clings to the bar stock, creates a hydrodynamic effect to stabilize the bar. In addition to the channel set, at the front end of the bar loader, we have an anti-vibration device, which is basically sets of bushing blocks specific to the size material that you're using. As I mentioned earlier, the bar feed is fully controlled from the CNC. That concludes the overview of the layout of the BNX 51 MSY machine. Let's take a look at a part being run on this machine. We start off using a double turning holder to rough the front side and the back side with 80-degree tools. The part on the right side and the sub spindle has previously been machined in the last cycle. We're using brass in the machine for demonstration purposes, but the speeds and feeds used are for stainless steel. The next operation, we are finished turning the front side and finished turning the back side, again utilizing this double turning holder. The next operation, we come in, we groove the front side, groove the back side, a relief for threading. Then we thread the front side and the back side, 2 different pitches. We are using the simultaneously threading option. We come in, we clean the back of the grooves and the threads. We come in, we spot drill the front and the back. We drill the front and the back. This toolbox can accept 2 tools on the front side and 2 tools on the back side. In this synchronous mode, the sub spindle will compensate for the rapid motion of the turret that is drilling on the front side. Utilizing the Z double spindle unit, we are machining a hex on the front and a hex on the back using milling interpolation. The C1 of the main spindle is working with the X1 on the turret to interpolate the hex on the front, while the C2 and X2 of the sub spindle interpolates the hex on the back. You can do this with the powerful Mitsubishi M70 control. Makes this task extremely easy. We are ejecting the part on the back side into the parts basket, then onto the conveyor. Well, the cross slide tool is now being used on the front side to engrave the outer diameter of the part. An extension was used to hold a small engraving tool. 2x speeder live tools are available if needed. Another live tool is now working on the front side. We have a special mill that allows us to interpolate a threaded hole at 45 degrees using the X, Y and Z on the turret. No need to spot drill, then tap. The universal drilling unit has been preset to a 45 degree angle. Unfortunately, all the action is at the far side of the part, so we don't have a great deal to see. The cutoff tool is being used to create a milling relief for the next tool. Another live cross mill drill holder is used to machine a boss on the outer flange of the part. The tool is being stepped down after each pass, approximately 25 thousandths. This is another tool that allows the use of through the turret coolant. Finally, a live tool is now being used to chamfer the boss on the outer flange. Now we pick off and cut off the part. First we will synchronize the spindle rotation, then grip the part with the sub spindle. Now we will open the main and pull out more bar stock for the next part. Then we cut off the part. That completes the cycle. We can choose to finish the part in the sub spindle with the use of the last part key on the panel if needed. Otherwise, we could keep running in continuous operation. Let's take a look at some of the features on the control. The control is a Mitsubishi M70 control. It's a control we have on quite a few of our machines. If you watched the demonstration earlier on the L20, that machine has basically got the same control. So here we start off on the preparation screen. First screen that comes up when we power up the machine. It comes up, and that's just what program we want to run. Just hit enter. So when I hit enter, it comes up with the machining data page. Those of you who are familiar with our Swiss style machines will recognize this page. So within this page, it asks us what the stock diameter is, what clearance point we want above the bar stock for automatic cutoff. So as I go through, it's showing us graphically, it's identifying each individual section with a graphic. So we've got the cutoff tool number, cutoff tool width, cutoff speed, cutoff feed, cutoff end. Basically for automatic cutoff, we can have different speeds and feeds within the program. One of those items is machining length. If we're in tube stock, the position of the cutoff, what clearance do we want for the cutoff between the tool holder and the main spindle. The backwork length, how far do we want the part sticking out of the sub spindle when we chop the part off. So the machine, when we pick the part off, we call up a special code, and the machine automatically figures out where it needs to be to pick off the part. It knows that because of the machining length and the backwork extended length. How far do you want the part sticking out? If we're using the stopper, we would tell it what number the stopper is. It's asking us the length of the spindle 1 chuck and the length of the spindle 2 chuck. Depending on what you put on the machine, you might put a 6-inch 3-jaw chuck on the main spindle. If you did, this number would change. If you put a 5-inch chuck on the sub spindle, that number would change. So depending on what we put in here, obviously would affect how far the machine goes to pick the part off. But the machine's looking out for you basically once you give it this information. And the last one is tool holder name. I'm going to go into the tool set page next, but that selection there allows me to choose a free tool layout or free tool. It might be a tool holder that you designed yourself that you can call up the geometry. So I'm just going to move on basically to what I would call the tool set page. So the tool set page obviously lists the 12 stations on the turret. Each one of those stations has got a different tool block in. So on this machine, I don't just call up a tool, I actually define what tool block is in that particular tool station. You can see in position number 1, I have a cutoff tool. Now if you're setting up a job, you'd basically want to set the holder for station 1. So I hit holder set, then I've got choices on the right hand side. As I go through the tool files, you can see it's calling up different tools. So if I cursor down, we look at a few more. So here's a tool, for instance, our tool holder. It's got 2 pockets on the front side for sleeves. It's got 1 on the back for a turning holder. So if I want to set that holder, I would just hit input. So the machine's asking me, do I really want to set that holder in station 1? I'm going to say yes. So once I do that, it gives me choices. It's asking what offsets I would like to designate to each one of these 3 positions. You know, maybe you're not using all 3, and you don't have to obviously put 3 different offsets in. But H1 is the outer position on the front side. So this is tool 1. So I might just say, right, okay, H1 or pocket number 1, I'm going to use offset 1. Pocket number 2, I might say I'm using offset 21. I'm choosing 21 over 2 because I've got a station 2. In H3, if I was putting a turning tool in the back, I might call that offset number 31. I don't know if you can see on the screen, but each one of these positions, the machine already knows what spindle that pocket is used to machine on. So if I try and do something strange in the program and try and maybe drill with this position on the sub spindle, the machine's going to alarm out. It's going to say, you really can't do that. Now when I call up the holder, the machine drags out data for that particular tool holder. So I've now basically set this tool in one, so if I hit escape, you can see now I've got the 3 sets of offsets. H2 and H3, they've got no values in there, but it's showing me that H1 and H2 are face tools, in other words, they're drilling type tools, and H3 on the back end is an outside diameter tool. So when I call the holder up, the machine drags out geometry from the tooling files pertaining to each one of these positions. We have data in the diameter and the longitude at this point in time because tool 1, offset 1 on the last tool, remember, it was a cutoff holder. It's still got the old data in. So if I was physically going to set this holder up, the first thing I'd do is clear out this data. So the machine knowing the geometry for this holder, that would mean if I wanted to drill in any of these 2 stations on the front side, I would just call the tool up on the offset. I wouldn't have to put any additional tool geometry in the diameter to get the tool to move on center. Obviously the longitude would change depending on the varying lengths of the drills or whatever you're using in that station. So you could go through there and set each one of these pockets with different holders. Now when I output the program, it's going to take this data with me. So the next time I set the job up, if you have the tools on a cart and you put all the holders in the machine, you just call up the program, all these tools would be already set, all the geometries. So it would overwrite the geometry that was already in from the last job. I'm just going to quickly go through and I'm going to call that cutoff tool holder up again. I'll just page up. So as I say, graphically I can see what holder that I want, and it's actually that one there. I'm just going to hit input and say yes. So I was using the cutoff in there at 1. I can put another offset in there if I want to use the same tool on spindle 2. I'm not using the tool on spindle 2 with that cutoff, so I'm just going to hit escape. And once I do that, you can see that's just gone back to where it should be. Now one of the good features too on this machine is if I want to index a tool, I can just cursor to that tool and then I can say tool select. So right now if I hit cycle start and we look in the machine, it's going to clear the axis out the way and it's going to index to that particular tool station, which is station 5. Now I made an index to station 5 to maybe I wanted to take a look at the insert. Maybe the insert was chipped, so I wanted to inspect the insert. What I can do on the tool selection page is I can go back into tool select, and if I cursor, I've got different options to do different things. So this here is asking me, once the tool is called up, what do I want to do? So after calling up the tool, I can tell the X to move in. So I'm actually going to do that with a different tool. So I'm going to go to tool number 2, tool select, I'm going to cursor down, and I'm going to call up option number 2, which says index to station 2, but when you do that, bring the tool in. So in this type of scenario, I'd want to do that, maybe to change the insert or inspect the insert. So I'd change the insert, and then I might send that turret back home. So if I wanted to do that, I'd really want to either go back to 1. So I could say tool select, and cursor down, it's probably still on 2, which it is. Type in 1, and hit start. So I was already at that station, it just moved back and cleared out the way. One of the many features on the Mitsubishi control that we've had on our Swiss machines for a long time is the program check function. I think a lot of you from our Swiss world are familiar with it. So in program check, I can actually high speed check the program for syntax. In other words, no motion, it'll just run through the program and check. Or I can utilize turning of the handle as I run through the program. So I'm going to go handle 1 cycle, and I'm going to hit cycle start. So once I hit cycle start, if we look into the machine, nothing's actually started moving. Nothing starts moving, start cranking the handle. The first operation on this part is actually doing the rough turning. So obviously, with a lot going on this machine, if you were setting it up for the first time, you might want to use program check. We don't want an expensive crash. So better that I can stop at any time. At this point in time, I'm just going to hit reset. Now obviously things are very close there. If I want to, I can just send the machine back to what's known as start position. Start position is basically with the stopper tool at the right location and the axis cleared out the way. Now if you're watching the L20 presentation earlier, in the Q&A section, someone asked, can I start the program halfway through? The answer to that was negative on the L20. On this machine, in program check, I can search to any tool and rerun a tool. So basically to do that, I'm going to hit end search. So I'm going to search for a sequence number in the program. You saw this test part running in the video. Obviously, there's a lot of things happening at the same time. So you certainly need to construct the program in a fashion where it's safe to be able to start the program halfway through. That's very easily done. It's been said before about the programming on Cincom lathes. It's the same on this machine with a Mitsubishi control. It's simple. Yeah, it's different. It's one program with 2 lines of information, and this the case on this machine. But with a little bit of education from one of our first-class engineers, you can learn to program a multi-axis lathe pretty easily. So anyway, back to the drawing board here. I'm going to say tool, rather sequence number 2000. So I've searched for sequence number 2000. I believe it is the finished turning tools. So now it's coming in and it's doing the finished turning on the part. It's finished the turning, so at that point in time, as I say, you might have just changed the insert, you might have had to rerun the tool, you might make an offset, change the diameter. If the part is too large, obviously we could make the offset and rerun that tool. I say we can rerun any tool that I have on this demo part because of the way I've constructed the program. If we run it through after we've changed the insert and the part is too small, we can hit this button here, and if we go back through and program check, we can put the material back on. That is not true, by the way. Anyway, it's a very nice feature on this machine, being able to search through and rerun tools. That's what most people do on typical lathe type applications. So after the review of the control, basically what I'd like to do is just mention that, remember, the bar feed and the machine are entwined, they're plugged in. The bar feed is controlled off the CNC. So when you make that call for service, you only call up one company. You call a distributor, you call up us. We handle the bar feed, we handle the lathe. Options for this machine, I mentioned about the turret. The turret, we have up to 1,000 PSI capable through the turret. So we can have high pressure up to 1,000. We have mist busters. We have our tech center in New England that can provide maybe auto loading solutions, auto extracting solutions. So with that being said, I believe at this point in time, finishes the control. If you have any questions, I'm here to answer them.
Okay, this is a good time to send in your questions. There's a short delay before the questions appear, so be patient with us. I have a few quick questions right off the bat, Tim. Can you install a quick change collet system on the main and sub spindles?
Quick change collet system. As I mentioned, the nose of the spindle on the main is an 826. Sub spindle is a 110 millimeters flat. Those are standard nose systems. So yes, you could install a quick change system. Obviously, you've got to think about a low profile. The max chuck diameter we have on the front side on this machine is 6 inches. The max on the back is 5 inches. So if that quick change system fell within those parameters, diameter-wise, you could put it on the machine. You got to remember that through the machine and data, I mentioned about the lengths. If you bought these quick change chucks and put them on the machine and the lengths were different, you'd plug those lengths into the machine and data, and that's all you'd have to do. The machine would know where to go to pick off a part. So you wouldn't lose any automated pick off in sync ability. You know, you haven't got to recalculate the positions on the machine. If I put quick change chucks on now, I could basically put in the values on the front and back and run the same part. I wouldn't have to change any positioning of the tooling or anything else.
Thank you. Can a high pressure coolant system be installed?
Yep, as I briefly mentioned, we can put up to 1,000 PSI through the turret. A lot of the blocks you're seeing, in fact, a lot of the blocks that are come standard with the machine, cut-off holder, turning blocks, drilling blocks, they're already cooling through capable, obviously for the medium pressure, but that handle 1,000 PSI also.
I see you have a full-length bar loader here. Do you sell a short bar loader for this machine?
Actually, we do. We sell an MSL 65. It's actually a 65 millimeter capacity, so it's over capacity for this 51 millimeter machine, which is really good. It's obviously that much more rigid and beefed up construction, let's say. So yeah, we could put a 4-foot loader on, a 3-foot loader. Obviously, there's parameters as far as the enclosure of the main spindle. This particular machine, I believe it runs at about 29 inches in length. So if you had a 3-footer you wanted to run, there is extensions for the spindle you could buy to allow you to run a 3-foot bar, or maybe even a 4-foot bar. So, yep.
Thank you, Tim. Are there any other questions?
No more questions. So I think what we're going to do now is go over to the US Bank specials we have. I think we've got a slide to show. So we've got some special financing options through US Bank for a limited time. There's a deferred payment option where there are no payments for 5 months, then 55 equal payments. There's a structured payment option, which is 9 months at 1% of the financed amount, then 51 equal payments. And finally, fair market value lease option or FMV option, which is 3 months at 0 money, then 57 equal payments. Your distributor can supply you with further details as far as that financing. In addition, we have a limited amount of specially priced machines, Cincom models and Miano machines that are available during this special event. For further details, contact your MCC distributor or can be found at marosit.com. As a reminder, we will continue our MCC Tech Days from our Fountain Valley office tomorrow. Please try and join us. Thank you for watching. I hope to see you at a machine tool show in the near future. Take care. Bye.